Have you ever looked at a globe and thought, is this really what our world looks like? For most of us, the answer is a simple yes. We learn about our spherical planet in school, see it in images from space, and accept it as a fundamental fact. But what if I told you there are groups of people who passionately believe our world is not a globe at all? Today, we're diving deep into two of the most fascinating and persistent alternative theories about the shape of our planet: the flat Earth and the hollow Earth. We're not here to debunk or to prove, but to explore the ideas, understand the communities behind them, and see what keeps these theories alive in the age of modern science. So, buckle up, because we're about to take a journey to the very edge of belief and beyond. Let's start with perhaps the most famous alternative model: the flat Earth theory. The core idea is simple. The Earth is not a sphere, but a flat, disc-shaped plane. In the most common version of this model, the Arctic Circle is at the center of the disk, and Antarctica isn't a continent at all. Instead, it's a massive wall of ice, hundreds of feet high, that encircles the entire edge of the world, holding in the oceans. Think of it like a giant, cosmic snow globe, but with us living on the flat base inside. So, what about gravity? If the Earth is a flat disk, why don't we get pulled toward the center? Flat Earth proponents have a different explanation. They suggest that the disk is not stationary, but is constantly accelerating upwards at a rate of 9.8 meters per second squared. This constant upward motion creates the same effect as gravity, pinning us and everything else to the surface. It is a clever way to explain the sensation of being pulled down without needing a massive spherical core. And what about the sun and moon? In the flat Earth model, they aren't colossal celestial bodies millions of miles away. Instead, they are much smaller, much closer, and circle about 3,000 miles above the plane of the Earth. Imagine them like two spotlights moving in a circular path over the surface. This movement is what creates day and night. As the sun circles overhead, it illuminates a portion of the disk, creating daylight. When it moves away, that area falls into darkness. The seasons are explained by the sun's path spiraling in and out. During the northern hemisphere's summer, the sun's circle is tighter and closer to the center, and in the winter, it spirals outwards. But this raises a lot of questions. What about sunrise and sunset? Eclipses? Time zones? Why can we see different stars in the northern and southern hemispheres? Proponents have developed intricate explanations for all of these phenomena. For sunsets, they suggest a law of perspective makes objects appear to sink below the horizon as they move further away. Eclipses are sometimes attributed to an unseen anti-moon, or shadow object, that occasionally passes in front of the sun or moon. The varying star fields are a trickier point, but some models propose complex light-bending effects or simply contest the observational data itself. A huge part of modern flat Earth belief is the idea of a massive global conspiracy. Why would anyone hide the true shape of the Earth? According to the theory, space agencies like NASA are at the heart of it all. The claim is that they've been faking space travel, satellite communications, and images from space for decades. The motivation? It varies depending on who you ask. Some say it's about controlling humanity by hiding the true nature of our existence, or perhaps concealing vast, undiscovered lands beyond the ice wall. Others believe it's a financial scheme, diverting trillions of dollars in public funds into a fake space program. This conspiracy element is crucial, as it provides an all-encompassing explanation for why mainstream science and evidence seem to contradict their model. Every photo from space, every GPS signal, every circumnavigation of the globe is dismissed as part of this elaborate hoax. Now, let's journey from the edge of the world to its very core, with the hollow Earth theory. This idea is, in some ways, the polar opposite of the flat Earth. It accepts that the Earth is a sphere, but proposes that it's not a solid ball of rock and magma. Instead, it's a hollow shell with a whole other world inside. The Earth's crust is said to be several hundred miles thick, and within it lies a vast, open interior. But how could a world exist inside our own? Proponents of the hollow Earth theory suggest there's an internal sun, a small star suspended right in the center of the hollow sphere, providing light and warmth to the inner surface. This inner world is often depicted as a lush, prehistoric paradise, possibly inhabited by lost civilizations, dinosaurs, or even beings from another dimension. Think Jules Verne's Journey to the Center of the Earth, but presented as fact. Where did this idea come from? While it has roots in ancient mythology and folklore from various cultures, the modern hollow Earth theory was popularized in the 17th century by Edmund Halley, the same astronomer Halley's Comet is named after. He proposed that the Earth consisted of concentric shells, each one potentially inhabited, all rotating at different speeds and surrounding a central core. He thought this could explain strange compass readings. Over the centuries, the idea was adopted and adapted by various writers and thinkers. One of the most famous proponents in the 19th and early 20th centuries was John Cleves Symmes Jr., an American Army officer. He was so convinced that he launched a campaign to fund an expedition to the North Pole to find an entrance. He believed there were massive holes at both the North and South Poles, often called Symmes holes, which served as portals to the inner Earth. His theory captured the public imagination for a time, though his expedition was never funded. So, what's the evidence for a hollow Earth? Adherents point to a range of supposed clues. They interpret ancient myths about underworlds like Hades or Sheol not as metaphors, but as literal historical accounts of the inner Earth. They cite strange seismic data or anomalies in the Earth's magnetic field as potential proof. Some even claim that unidentified flying objects, or UFOs, don't come from outer space, but from advanced civilizations living inside our own planet, emerging through these polar openings. Admiral Richard E. Byrd's polar expeditions in the mid-20th century are often referenced. Hollow Earth believers claim that in his secret diary, Byrd wrote about flying into a polar opening and discovering a temperate, green land with mammoths and a lost civilization. However, mainstream historians and Byrd's own public records show no evidence of such a discovery or diary. Both the flat Earth and hollow Earth theories have a powerful appeal. They tap into a deep-seated desire for mystery, for a world that is bigger and more wondrous than it seems. They also cater to a distrust of authority and a belief that we are being lied to by powerful institutions. In a world that can feel thoroughly mapped and explained, these theories offer a return to an age of exploration, where giant secrets could still be hiding just beyond the horizon or right beneath our feet. The communities that form around these ideas are incredibly tight-knit, connected by a shared worldview that sets them apart. Through online forums, conferences, and social media, they share evidence, develop their models, and reinforce their beliefs against outside criticism. Ultimately, whether you see these as dangerous misinformation or harmless flights of fancy, the flat Earth and hollow Earth theories are a fascinating window into human psychology. They show our capacity for belief, our need for community, and our endless curiosity about the world we inhabit. They challenge us to think critically about how we know what we know, and to understand the power of a compelling story. What do you think is the most intriguing part of these theories? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey into the world of alternative cosmology, be sure to like this video and subscribe for more deep dives into fascinating topics. See you next time.